Hi, this is JP Auclair, and today I'm going to show you how to use the new FlashPreloadProfiler Release Candidate 1. If you want information on how to install the profiler, you can go to my blog and read all the information there with all the comments from the other users. So let's start with the basic feature. Once you have the profiler loaded, you will have that little bar on the top, very small, very with uh, transparency in there. So there is new tooltip in this version. You have new tooltip. So each of the buttons here have the description to know what they do. So basically, you have the minimize button that just hide all the windows that might be open. Oh, and by the way, I'm currently profiling some custom shape particle system written on ActiveDen. So yeah, it's just a little particle system there. So let's start with the first feature. So runtime statistics. This is basically some information on the current frame per second, minimum, maximum, and the memory information, basic memory information that you can find. You also have the memory allocation graph, which show you in red the maximum memory used, and in blue the current memory. You have in the menu you have that little trash can, which is force sync garbage collector. It's using the local connection trick to trigger the garbage collector. So if I click that, I can click a few times, or one or two or whatever, and here's the drop. So the garbage collector has been forced there. This is oh, and on the top right here you have the little gradient icon, which is only to modify the transparency of the profiler ad itself. So I'm just going to set it back to more transparent here. The next icon is the mouse listener. So in a game or in an application where it's based on movie clips or on the display list itself, you always have those mouse listeners on many objects. So this scene is very small for this example, but you have that next button here. So I might click and it's going to work, but here, next example. So it's part of the Swift itself, and when I go to mouse listener, I see that it's clickable. This screen also show in other colors when you have a listener in a sprite that isn't visible, or it's hidden, or a bit behind another mouse listener. So you have more information on more complex Swift. The next icon is the overdraw. The overdraw is only showing you all the layers of the movie clips in the scene. So when I say movie clips, I'm also including sprites and shapes and whatever, all the display object. So here you can see a lot of clips going one over the other, and on the bottom you can see the max depth. So there's at maximum 6 at child hierarchy. So yeah, and you have that display object on stage. So there's about 128 sprite on this scene. You also see in yellow, I think I can, if I can remember correctly, you can also see in yellow when you have alpha 0 sprite and hidden sprites in there. So you have triggers showing you that you have stuff that are part of the display list but aren't actually visible. So yeah, you also have the next icon is the display object lifecycle, which is very interesting, and in this case very Christmassy. So here's my Christmas tree, and so what you see in there is information on what sprites are created, are new, are collected, and are removed. So you have the little colors on the bottom of the screen showing you Yellow is create, red is reused, removed, and waiting for garbage collection. The waiting for garbage collection is kind of cool feature because you can see in some website you can see a lot of stuff waiting for garbage collection, and they are still, in most cases, they are still animated and processed. So this is a very important information to have. You can find bugs so much faster using that kind of graph. You also have all the display object on stage, added to stage per second, removed from stage per second, and waiting for garbage collection. So there's between 30 and 80 sprites waiting for garbage collection each second. Okay. If I click the next example here, it's not all the particle systems that aren't that have so much instantiation. So in this case, there is a lot of sprites being removed, and many are being reused. So you can see all the blue and the red, which is a good sign of reusing. So this particular example is kind of optimized. Okay, let's go back to the nice one. So here is the memory profiler, and okay, so in the memory profiler you have all the object being allocated, and they are by default sorted by the cumulative instance. So you can see all the object added in the last second, all the object removed in the last second, current count, and the cumulative count. This is the added and delete part, which isn't in the flex profiler. Is kind of cool because you can see here that the cumulative is going up, but the current isn't. So those 30 objects in the event here are allocated in one frame and removed in the other one. So they aren't garbage collected because they would show up in on many frames, but they are part of the reap phase of Flash. So they are collected instantly in one function, and in many cases you can optimize a lot of code by just removing useless instantiation. So this is one case where you could, well, this isn't because I guess it's an interframe or something, but in most cases when you see equivalent number in the add and delete, you can go and optimize something there. Okay, so well, this is pretty simple. So you have all the object. In this menu you have many objects like clear current data, so it's just going to reset the whole state. So if you look at the cumulative instance here and I delete and clear the current data, it's just going to clear the whole thing and start back from scratch. You can also save all the memory allocation in the clipboard, so let's do it. Save it. It's saved, and now it's part of my clipboard. So if I go in well, here's a text editor, so I can paste it, and it's all the same columns, and you can just use it as you want. And one thing here is the start recording sample. So this feature is very useful because it's just going to dump the all information on sampling. So memory information, function performance information, basically all the times associated with Flash action, so allocation, garbage collection, function time, and everything else. So if I start recording, it's right now it's recording. You can see it's keeping yellow, and if I click again, it's processing all the data, it's saving it to the clipboard, and I can now again paste it. It's in a format that you can use in a grid like Excel. It's going to work perfectly. And on the left you have the instantiation time. As you can see, there's so many lines. I just recorded for 2 seconds, and now I'm 24,000 lines. So on the left it's the time in microsecond, And the next column is the time took by the line itself, so it's 5 microsecond to do the new instantiation here of a shape. And then it's you have many samples, so that is a new. There's deleted object, there's function time and other samples. And in many cases you can find the stack trace here. So the stack trace just follows. So the new object on this line is being allocated at somewhere in the add child of that framework. So yeah, you can do a lot of things with those samples. So it's basically just a dump. And okay, the next icon is the internal event profiler. So this is kind of tricky, and I'm not sure yet on how to interpret all those data, but I've put the 12 most 12 samples that I got the most often. So you have to verify interframe, and to have all those definition and what all those events do. I guess you can browse on the internet a bit. A few information that are practical are the mark and sweep. So in yellow and in red, you have a few mark and sweep here. If you have too much of those, I guess your application should be optimized. And you have a lot of time in the pre-render here, because all the management are sprites in the displays, and you have some free time, so the application isn't taking 30 all the time it could take. So there's some free time here that could be used, and this is it. So each second I had a line showing the repartition, the ratio of what event takes what time. Oh, here you have that little timer on the top right corner. You have the little timer. It's just to set the refresh rate, so increase the refresh rate and decrease the refresh rate. Okay, so the next item is the performance profiler. So this is one new big new feature of the release candidate 1, and it's showing function name and the time took by the function, self time and total time, with time in microsecond and percent of the process. So in this application you can see that most of the biggest events are flash events, so it's not even the management of the particles and nor the management of the scene or whatever. It's mostly in flash rendering process. You can see the shape here. Some time is spent on the shape particles update and initialize. If we would go lower than those, because I just stopped at the height of the screen. If we would go lower than those, there would be my code of well, the profiler, because I'm not excluding again to keep performance high. Sorry. You have the stack here. So when you go to a function, you can always see the stack. If you click, it's going to keep it on clipboard. So oops, a problem here. And yeah, okay, so you have the sorting aspect here, and now it's crashed. Sorry. Let's start again. So you have all the information and the time, and you can sort between self time and total time. So you could say what is being heavy here is mostly the let's say the interframe and the shape particle update. All those shape particle things are part of the uninterframe here, and are part of the main interframe event here. So that is one feature here, one of the big new feature. You always have this little help, which is say what the tool is about, and